Okay, so I've got to close this door. Okay, all right, so we are in the process of moving through in the algebra. We're in week 3 now. Just a note, there was a change on the homework. There's a couple of problems added. I have it on my list when we get to that part. All right, so we've already talked about quiz 1. All right, and just for the sake of people that aren't here, but are going to be responsible for it, you're supposed to take the quiz, correct the problem that you got wrong, then do the rework problem that's associated with that number. So if you got 3 problems wrong, you're going to go back in the book and you're going to use 3 specific problems that have a similar skill to the one that you were working on when you thought you gave me the right answer. Okay? And the 3 most common mistakes were, 1, using an operation sign, a times sign, with that first problem, when in the best algebra form, you should not have 1/9 times C, you should have just had 1/9 C. All right, that's the first thing. Second thing that goes along with that is that there was a problem that had division in it, and we do not use the little marks, dot, line, dot for division anymore. We use a fraction. Right? Again, those are things that you have to learn. So I was extra mean on this one so that you'll get quickly changed into writing the right way. And then I've already talked about this. In Algebra 1, you have the use of calculator. And this is relatively new for 8th graders because in the state system, 8th graders can use a calculator with algebra, but when they take the state test, they couldn't use a calculator. And so that made it really tough. So this is much more fair. Any arithmetic problem. We were talking about this a little earlier with the teachers. When I was in public school, and I would have a problem, and I would say, okay, what is 6 times 7? As I was working a problem on the board, I would get 3 answers called out, and probably none of them was 42. Because there were people that had the wrong idea of what that math fact was. They mixed it up, or some said 44 and stuff like that. But in algebra, you can use a calculator. So if you're not 100% sure what the math is, use your calculator for the arithmetic. Okay? Now, what you do with the algebra part, like on these other 2 signs, said those things you have to learn. That's what this class is about. But the arithmetic part is now made much easier because you have use of that calculator, and if you don't, shame on you. Okay? All right, so that's the first part. Now, what we're going to do, to start with, let's see, I've got a number 2 quiz because we're right at the end of chapter 1. And so I'm going to pass out the number 2 quiz of 5 problems and an extra credit. And you have about 10 minutes to finish. This is not hard. It's the things that we've been doing. Okay, so what are the things that you're going to look for when you are taking this test? All right, should you make these mistakes? No. Should not. Hopefully you learn, right? You're going to learn and you're going to put that into practice. And this one's actually easier, I think, than the first one. Okay, so let me pass the papers out and you may begin once you get your paper. the reasons I'm going to leave the film on is because it allows it to be one continuous file for the people who are going to upload it. They don't have to upload two files. Again, when you're finished, please turn your paper over. That helps me see who's still working. If you get stuck on a skill, skip that problem for just a minute, finish the rest of them, and then come back to the one you got stuck on. Maybe you'll remember. Don't waste too much time reading one problem before you finish. We have about 2 more minutes. Easier than the last one? What do you think? Easier? No? How many more you have?
Just like 2.
How many you got? 2? All right, finish the one that you're working on if you can, and then I'll let you come back and finish that later. You can come at lunch if you don't have time at the end of class. Okay, so just turn that, when you get finished, turn that paper over, and then I'll let you finish that one. Okay, all right, now, get your book open and turn to page 44. 44. You don't have to rush through it. You'll have time to finish it later, okay? All right, sorry. All right. Okay, now, all right, we are moving into chapter 2. All right, first thing that I would advise you, all right, I would advise you to go back to your notes and your homework. Look at the material that you wrote down to do the chapter 1 test, the problems that you had to do. Read over those to yourself. That should remind you, okay, yes, I know this skill, or wow, I forgot that. Let me look a little closer and read what was, oh, now I remember. Okay, go over your notes from the chapter homework, and when you're done, it'll be fresh in your mind, and then tell your parent, okay, I'm ready to take the chapter 1 test. Okay, if you try to take the chapter 1 test without going over in your mind what you were supposed to know, you might not remember some things that you actually know how to do. And so do your note study and then take the test. Does that make sense? Okay, all right, good. So you can do that relatively soon so that chapter 1 will be closed out, and then go start on your homework for chapter 2. Right? But don't forget the homework that you did for chapter 1 and the study of the chapter test that you did as homework is preparation for the test you're about to take. So don't forget it. Go back and use it. Now, that's my point. Okay, use it and then say, okay, now I think I'm ready, and then ask your parent for the test and go ahead and take it. Okay, does that make sense? All right, so now we're going to move into chapter 2. And the first question is, what are integers? You're going to hear that number a lot, integer. Okay, integer is a positive or negative whole number. Now, what does it mean if it's a whole number? Obviously, somebody answer that. You can answer that. What does it mean if it's a whole number? Then it doesn't have a what?
Decimal.
It doesn't have a decimal part, right? It has a whole, it doesn't have a fractional part. It's just whole numbers, right? And so I have put the dots where the whole numbers are, right? And integers are positive and negative. All right, this is something that's used in algebra, especially in Algebra 2. These brackets are called set. As in, this is the set of numbers that goes from negative infinity through -3, -2, -1, 0, 1, 2, 3, and positive infinity. But if you'll notice, all of them are whole numbers, and these ellipses mean that it continues in the same way. All right? So, integers are whole numbers, and you used integers all through elementary school. Only you used half of them. All you used was the positive integers. All right? And so what's going to happen with some people when they get to Algebra 1, you already had it introduced in pre-algebra, is that you're going to have a problem remembering that I've got negatives to deal with, not just positives. Okay? So that's one of the things that we're going to try to center on in this chapter, is recognizing what is the sign of the number. Is it a positive number or is it a negative number? Okay? So that's what we're going to do. So we're going to talk about integer rules for adding. All right? What have I written here? What's that say? Read that. Write the sign first. Okay? So if we look at page 44, the problem's on page 44. You have, the way that I view this in my mind, I have, the first number is a 5, right? Is it a positive 5 or a negative 5?
Positive.
It's positive 5, right? So if I have number 1, oh boy, look at that. Hope they're not all that way. Plus what? What does the book say?
-2.
5 plus -2. All right, now equals. All right, if this was 5 plus 2, we know the answer is 7. So 5 plus -2 is probably not going to be 7. Okay, now, one of the things that we have to understand with integers is 1 positive plus 1 negative equals 0. They are called additive inverses. When I look at this, I have 2 negatives. If I split these to 3 plus 2 plus -2, now, by the associative property, instead of doing the 5, I could group these. And what is 2 plus -2? 0. And so 3 plus 0 is 3. Right? That's the long way. But that's the mathematical approach that we have to take. All right, so if I can make 2 zeros, then what am I going to have left when I take 2 away from 5? The answer is 3. All right, now, what I would like you to see you do is the sign of the answer is going to be the bigger stack. All right, so in here, which stack of numbers is bigger? 5 positives or 2 negatives? 5 positives is higher because it would be 1, 2, 3, 4, 5, and 2 negatives is only that high. Right? So this is higher, so when I add them, I'm going to have a positive something. All right? If these are different, I'm going to end up making some zeros. Which stack is taller? A 5 or a 2? Which stack is taller?
5.
The 5. By how much? 3. That's subtracting. So if the signs are different, you're going to subtract and use the sign of the bigger stack. All right, that's all it is. Now, what's nice is you have a calculator. All right, so let's do this with your calculator just to show you. 5 plus -2. The negative sign is under the 3. So with your calculator, pop 5 plus, and underneath the 3 is a negative sign, -2. then press enter. It's a tree, right? Tree. Okay, so if you're allowed to use calculator, that becomes pretty easy. The calculator can do it for you. But what I want you to be able to do is to be able to do this without a calculator, understanding what the sign is. So problem 2, which stack is bigger?
7.
So it's going to be plus something. Plus how many?
4.
Negative.
Plus 4, because 7 minus 3 is 4. Okay, problem 3, what's the sign of the answer? Positive. Why? Because the 6 is a larger stack, okay? All right, problem 4, what's the sign?
Positive.
Positive, very good. Why? Because the 8 is taller than the 7. All right, number 5, what's the sign?
Negative.
Negative, why?
Because 5 is 2.
Because you got 5 versus 2. Right? Number 6. Negative, why? Because you have 10 versus 9. Isn't that simple? All right, okay, so if the signs are different, you're going to use the sign of the bigger number, and then you're going to subtract the two numbers to be able to get the answer. Okay, now I want to show you something. All right, let's say that I have this problem. 42 plus negative 37 equals. All right, if you put the sign first, all right, what's the sign of this answer?
Positive.
Why?
Because the 42 is
Because 42 is bigger. There's more, right? So my answer is positive. Now, in the calculator, I want you to do something really strange. I want you to put 37 minus 42. All right, but we know that this answer is positive, but it's going to be positive what?
5.
Positive 5. All I want to do is subtract these two numbers, and then I'm going to take the absolute value, which will give me the positive of whatever answer you have. Right? So the answer is actually the absolute value of negative 5 in the way that I put it in the calculator. But if I would have put it this way, 42 minus 37, then I would have got positive 5. Right, but do you see what I'm trying to show you? That if you know what the sign of the answer is, then you're not worried about what the calculator saying. But I can use the calculator to get the magnitude, how big an answer it is. Okay? Does that make sense? All right, so let's do one more real quickly this way. Okay, what do you know the answer is?
negative something.
Negative, right? Okay, everybody, that's not a rocket science, is it? Uh-oh. Okay, so the value is negative. Now, put 123 minus 57 in your calculator. It's 66, but we know the answer is negative, so the answer is going to be negative 66. All right, now, let's do the right thing. Let's put the negative 123, using that plus 57, and you'll notice you have negative 66. So if you put it incorrectly as it's written, you can get the right answer. But if you write the sign down first, then it doesn't matter which order you put it in, because you already know that the sign is whatever it is. Right now, that will save you in a test time. Putting the sign down first, and then if you have to do something else, at least the sign part's right. Okay, does that make sense? All right, so that's a trick. All right, so the greater stack. All right, so here's the rules, and I want you to write these down on your paper in your notes section. If the signs are the same, then add the numbers together. If the signs are different, subtract the numbers. And you've already written the sign down first, so you're basically done when you have two-digit numbers. Now this is not new. We did this in pre-algebra, those of you that were here. And I'm sure you did it with pre-algebra regardless of where you were. All right, so signs are the same, then add, signs are different, we're going to subtract. Now, the operation, though, is adding. So what this is saying is if I have -3 plus -7, this is an addition problem, and the signs are the same. If I have -3 plus 7, this is an addition problem, but the signs are different. That's what I'm talking about, okay? Now, so, if we look at this, the sign of this answer is negative, because the 7 is negative. What's the sign of this answer? Positive, okay? What am I going to do with the 7 and the 3 here?
Add.
Add them because they're the same. What do I do with the 7 and 3 here?
Subtract.
Subtract them. And because I showed you in the calculator, does it really matter which one you put in first?
No.
No, it doesn't. And then your calculator is a tool helping you get a number because you already know what the sign is. And the same thing, if I would have switched these around and had it this way, I know my sign is negative, and then I'll go 3 minus 7 in the calculator and get -4. Okay? Now, if you will approach your integers that way, you're going to make less mistakes, I think. Okay? All right, so that's that. Now, let's talk about the book. Page 44 and 45. This is just punishment work now. Okay, and we've got to stay with what the numbers were assigned to you. So let's look at number 18. Let's look at number 18. What's the sign of number 18? Sign of number 18, Kara. What's the sign going to be? Negative. All right, slam dunk. Everybody's got that. All right, number 23, Eliza. What's the sign going to be for 23? Why? Because the negative number is larger than the positive number. Good. Okay. All right. Now that takes care of chapter 2. All right. Let's turn over to page 50. Page 50. That's just more of the same, isn't it? Okay, but we know the rules, so look at problem, I can't even make it hard. Look at problem 9 on page 50. All right, Hannah, what's the sign of the answer going to be?
Negative.
Negative, and what are you going to do with those two numbers?
Subtract.
Subtract them, right? And we're going to get 14, right? -14. All right, number 11, is it Kennedy, is that right? Okay, number 11, Kennedy, what's the sign of that answer going to be?
Negative.
And what are you going to do with the numbers?
Add them.
Why? Why are you going to add them? All right, right here. Because the signs are the same. See, we're not looking at the plus sign in between those two numbers. We're looking at whether or not the signs of the numbers are the same. And that's going to be clear in a second because I'm going to talk about subtracting. All right, does that make sense now? Okay, all right, so let's go to number 20. All right, Kennedy, number 20, what's the sign of that answer going to be?
Negative.
All right, and what are you going to do with the numbers?
Add them.
Okay, now in number 18, what's the sign going to be?
Negative.
All right, but what are you going to do with the numbers?
Subtract.
Why?
Because they're different.
There you go, you got it. Okay, once you get that, it's over. Now, I said with the pre-algebra, and you guys know, if I gave you a test, and the test is what is 2 plus 2? All right, that test is not hard. It is not hard. That test is impossible if you're 3 years old. Because people that are 3 years old, very few of them even understand. They haven't been taught anything at all about addition. Right? Okay, this skill is easy if you know and remember this, and it's impossible until you learn these. Okay, so that's the whole problem that we're trying to deal with. We're trying to learn something so that we have the base knowledge in our mind so that when we see the problem, we don't fall for the trick, we do it the way it should be done. Okay? All right, now, let's go to subtraction. All right, and when I taught in public school, we don't do subtraction. And we're not going to do subtraction. Because we have rules for addition that are too simple not to use. So what we're going to do is that we're going to change the subtraction problem to an adding problem. And we're going to use copy, change, change. Copy, change, change. And the reason that I use that instead of copy, change, flip, or something like that, is that copy, change, change makes two changes. And if you make two opposites, you're back to the same way again. Right? If you turn around, and then I turn around again, I'm doing the same thing. So if I go this, if I go copy, change, change, the whole process is going to be the same. So mathematically, two negatives make a positive. Right? That's what we're dealing with. So what I'm going to do with this problem, oh, sorry, this is a little different, but we'll work with this one. Let me do another one first. If I have 7 minus 4, all right, that's an arithmetic problem from 3rd grade, maybe? Okay, what do you do with those numbers? Subtract them. Okay, now wait, we subtract them. If I go copy, change, change, what do I do with those numbers? I subtract them because the signs are different. Right? What's the sign of that answer? Positive, right? So this becomes positive 3. Right? Suppose I have this. 3 minus 7. Well, Mr. Belcher, you can't do that. You always have to subtract the smaller number from the bigger number. All right? And why was that true in elementary school? Because you only used positive numbers, you didn't use integers on both sides. Okay? Now, so what's the sign of that answer? It's negative, right? Because if I go like this, right? But 3 minus 3 is 0. 3 minus 7 goes below 0. So conceptually, you can handle that part, right? Those aren't the reason that we change it. -3. What's my math? All right, this one you don't know. You cannot see. You can figure it out, but you can't see. Okay? Now, let's do copy, change, change on this one. If I copy this, I have a what? 7. Change this, and then change this. Now, what am I going to do with, first of all, what's the sign of the answer?
Positive.
And what am I going to do with the numbers?
Add them.
Add them. So the answer is positive 10. You can't get that from that problem. You could, but it's not normal to think of it that way. That's the reason that subtraction needs to be changed to addition and use the adding rules. Not because you can't get half of them right, it's because you rarely get them all right unless you do copy, change, change. Right now, if I gave you on page 50, right, if your homework on page 50, remember all those adding problems? Are they going to be hard to do? No, because we know what the rule is. It's going to take some time to do it right. But, you know, if that's all you had to do, then you can say that's going to be an easy assignment. If we change all these subtractions to adding, then it's just like problem 50 on page 50, right? So if you change subtracting to adding, then you're guaranteed probably a 99. If you don't, you're going to end up with a 75. Because there's one problem you'll never get right when it's subtracting of integers. Right? And the same thing would be true with this one. Suppose I gave you -10 minus -3. Now, from a conceptual standpoint, if I start with -10 and I take 3 negatives away, how many are left? If I start with 10 apples and take 3 apples away, how many apples are left? 7. If I start with this and I take 3 of them away, I have 7 of them left. But that's weird. So let's do copy, change, change. Copy, change, change. What's the sign of the answer?
Negative.
And what do I do with the numbers? No, subtract them because the signs are different. Right? That's why you end up with -7. And the reason I'm talking about that is you cannot get that easily by looking at it as a subtraction problem. But if you change it to an adding problem, that's simple. Okay? All right, now that leads us to what's on the board over here. All right? You're supposed to know about distributing. And when we distribute, we take a number and we're going to multiply the values inside. Come on. So the first thing I have to do is do a copy, change, change here. So this becomes plus -4. So what am I multiplying by? I'm multiplying by -4. Inside. Here I do copy, change, change. And so I have 9 plus -8. Now, if those were just straight numbers, I would say that's 1. Right? What's 9 plus -8 is 1, right? Okay, but we're showing how the other part works. So if I distribute -4 times 9, that's -36. And then if I multiply -4 times -8, that's positive 32. And now I have 21 and 32, which I think I can do in my head. So 53, positive 53 plus -36, which stack is bigger? 53, so therefore my answer is positive, and then I'm going to subtract these two numbers, and so my answer is positive 17.
Don't you have to add the 21 to finish the question?
I did to get to 53.
Oh, okay.
Okay? All right. Good. Thank you. Thank you. All right. Now, I'll say this. All right. Gracie she thought I had made a mistake, and so she asked me a question, which was polite, right? But had I forgot it, right, then that would have helped the class not get confused, because if you see something that I say or do and it doesn't make sense to you, then there's at least one other person in this room that it didn't make sense to them either. Okay? So don't be afraid to ask a question, or don't be afraid to say, did you do that right, Mr. Belcher? Because sometimes I get ahead of myself and I skip a step where I shouldn't have. And I make mistakes. But I try not to leave it there. Okay? All right, so thank you for that. All right, and by that I'm also saying that you have the right to ask a question if I say something and you don't understand it. And sometimes you got to do this. All right, and I'll look, and in the public school, and I say, "Oh, John, great, what's your question? Can I go to the bathroom?" Which kind of sort of disrupts the whole learning environment. But if you have a question about what we're talking about, raise your hand, and hopefully I'll see it, and that'll be something that'll help everybody. Okay? All right, so in subtraction, I'm saying you must change subtraction to adding. You must. Now, in algebra, there's things that we did in the first chapter where you had to write down the step, and the step you already knew, and it was an easy step, but you were still supposed to write it down so that you show what the transformation is. All right, the same thing is going to be true for subtracting. All right, you will not get credit for a subtraction problem if you don't change it to an adding problem. All right, so what does that mean? Let's look at page 54. All right, and this is going to be part of your homework, so get a clean sheet of paper, and let's look at a few of these. All right, problem number 2. All right, now, this is how I do problem number 2. All right, copy it, 144 minus 441. All right?
Which question is it?
All right, we're at page 54, problem 2.
Okay.
Then, to do copy, change, change, this doesn't change. I would put a line across here, and then I would put the negative sign in front of the 40, in front of the 400. Now, once you get that, what's the sign of the answer?
Negative.
Negative. Okay? How are you going to get the answer, the rest of the answer?
Subtract.
You're going to use the calculator to do what?
Subtract.
Subtract. Why are you subtracting? This would be a test question. Why do you subtract the numbers in this problem?
Because the integers are different.
Because the signs are different. Okay? And so you're going to put that in whatever the answer is. Right? But you did the copy, change, change, and you put the sign down first, then it doesn't matter how you put those numbers in the calculator because you already know what the sign is. And you already know you're supposed to subtract. Now what happens if you press plus? Because I've changed the problem, I would have to say 144 plus negative 441 in the calculator. And you can do it that way. Right? But we already know it's going to be negative because that stack is bigger than this stack. Right then, what do you do with 4? You could copy 15 minus negative 21 equals. All right, if I do copy, change, change, I go copy, change, change. Now, what's the sign of the answer now? Positive. And what am I going to do with the two numbers? Why am I going to add them? Because the numbers have the same sign. Ta-da. Okay? All right. Now, I don't think, did we do 4? Let me see here. Yeah, we did 4. Okay, sorry. All right. Go back here. All right, multiplying. All right, when you multiply in elementary school, both numbers are positive, and so the answer will be positive. Okay. If you have one negative, the answer is negative. If you have two negatives, the answer is the opposite of negative, which is positive. If you have three negatives, the answer is the opposite of positive, which is negative. And if you have 4, it's the opposite of negative, which is positive. So 1 is negative, positive, negative, positive. If you have an odd number of negative multipliers, as far as the signs are concerned, not the magnitude, but as far as if you have an odd number of negative signs being multiplied together, then the total answer is negative. If you have an even number, then the total answer is positive. Okay, so problem 59. Problem 59, or page 59, sorry. Page 59, problem number 1. All right, what will the sign of that answer be? Negative. Problem number 2. I'm sorry, problem 3. Page 59, problem 3. What will the sign of the answer be? Positive. Problem 5.
Negative.
Problem 7.
Positive.
Problem 9.
Negative.
All right, good. Drop down to problem 23. There's 3 of them.
It's negative.
So it'll be negative, all right? In problem 25, there are 3 negatives, so it will be negative also. In problem 27, there are 4 negatives, so the sign of the answer will be positive. All right, problem 29, there's 1 negative. So the answer is negative. Problem 31, how many negatives are there? 15, so the answer is negative, because it's odd. All right. Problem 33, how many negatives? 18, so the answer will be positive. Now, both of those problems, number 31 and 33, the magnitude of the answer is 1. Because it's 1 times 1 times 1 times 1 times 1. And in public school, those problems, one of those problems was always on a test, and I could never get 100% of the students getting those problems right. Because they think it's multiplying, and they try to multiply the exponent times the 1 and end up with 15 or something like that. So please remember, that's a trick problem. Because when you multiply 1 times 1 times 1 times 1, the answer is
What?
1. Okay, so be careful. All right? Now, so again, after you get the sign written down, the number is what the number is. Okay, now turn to page 60. Turn it over to page 60. All right, here we're going to use a calculator. Right-hand side of your calculator, do you see the little up arrow above the plus sign?
Yeah.
That's called raised to. That's the raised to button. So if I want 5 raised to the 3rd power, in the calculator, I do this. Okay, go ahead and do that. Put 5 raised to 3rd power.
Negative 123. Or 5.
125. Did you get negative?
Yes.
How'd you get negative?
The question in the book. The question.
Oh, okay, I'm sorry. I was wondering. All right, good. All right, now, yeah, then what you had was this one. Okay, now, here's a question though. How many negatives are in the problem that's closest to me?
3.
No, there's only 1.
Oh, there's no parentheses.
This has 3 because of order of operations. Okay, so now, with a 3, that doesn't make any difference. But suppose this were, I'm going to change the number so it's a little easier. All right, suppose it were this. All right, now look at the board. Look at the board. Now, we know we can put this in the calculator and find out, but how many negatives are in this problem?
1.
1 negative. So the answer is going to be
Positive.
negative.
Wait.
The answer is going to be negative because this is negative 1 times 3 times 3 times 3 times 3. All right, this is negative 3 times negative 3 times negative 3 times negative 3. All right, now, if you do not understand that, there's another learning thing. All right, according to order of operations, what do I have 4 of here?
Negative.
I have 4 negative 3s. What do I have 4 of here? I have 4 3s, and then it's multiplied by negative 1 because one of the properties that you're supposed to be learning is the multiplication property of negative 1, which says negative 1 times x equals negative x. So that means negative 1 times 3 equals negative 3, or negative 1 times 3 to the 4th equals negative 3 to the 4th. So there's 1 unless it's in parentheses. Okay, what did I just say? There is 1 unless they're in parentheses. Everybody say that. There's 1 unless it's in parentheses. Okay? Now, what's going to happen when you see that on the test? You may or may not remember. Guess what happens if you don't remember? You'll get it wrong, and you'll have to do that problem, redo it, and then go back and do another one so that you learn how to do it correctly. All right, that's a tricky problem. Without a doubt, that's a tricky problem. And we used to start teaching that in 7th grade. So they'd see it in 7th grade, they'd see it in 8th grade, and when they got to college, when they got to high school and did algebra, they already knew it and they didn't get tricked by it. Okay. So we'll go back over that one. It's okay the first time you get tricked, but you got to pick that one up fast. Okay? All right. Now, so that takes care of the assignments for this week. And there's a change that's supposed to be on problem 2-3. And that is that 42, 46, and 50 are supposed to be added, and I'll explain why. Okay, 42, 46, and 50 are similar test problems. So let's go back to page 54, and let's talk about those. All right, turn to page 54. All right, so problem 42 is an absolute value problem. All right, now, put this problem, we're going to do problem 42 in your notes. All right, problem 42. So we're going to take absolute value of 2 minus 9. Now, the problem on the inside, if I did copy, change, change, is this. What is the sign of this problem, 2 plus negative 9?
Negative.
The sign is negative. What do I do with the numbers?
Is the absolute value.
No, I'm just talking about what's inside first.
We subtract.
You subtract them because the signs are different. So I have negative 7. Therefore, I want the absolute value of negative 7. The distance from a number to 0 is what absolute value is. But it's always positive. So, what is the absolute value of negative 7? Equals positive 7. Now, so these marks are absolute value marks. All right. When we test 2 things. What is the absolute value of negative 14? And what is the absolute value of 17? Okay? What is the absolute value of negative 14? 14. Positive 14. What is the absolute value of positive 17?
Positive 17.
Positive 17. Because absolute value makes it positive. Okay? And so, what is this? This is the opposite of the absolute value of 31. This would be negative 31. What happens if I put a negative sign in here? All right, it's still the same because of order of operations. I go inside first and say, what is the absolute value of negative 31? It's positive 31. And then what's the opposite of positive 31? It's negative 31. All right, now, the test for this chapter has an absolute value problem on it. And so we had to make sure that we went over it. So let's look at 44. Right now, the last thing that you're going to do because of the absolute value marks is that you're going to make it positive. So what's going on the inside? What do you see in problem 44? All right.
6 minus negative 4.
All right, so I see, all right, should you be doing copy, change, change?
Yes.
All right, so let's copy the problem then. Let's copy the problem. Absolute value, 6 minus negative 4, absolute value. All right? So, what happens if I do copy, change, change? I go copy, change, change. All right? The sign of this answer is positive. How many?
10.
Positive 10. What is the absolute value of positive 10?
10.
10. All right, so what happens in 46? That was almost too easy, didn't it? 9 minus 6?
3.
We're on page 54. Look. Okay, page 54, sorry. All right, page 54. All right, 9 minus 6 is 3. What's the absolute value of 3?
3.
3. 3 plus 5?
8.
You're going to hate that answer.
8.
You're going to hate that, right? All right, now 48. What are you going to do first? Negative 14 plus 3 is how much? Negative 14 plus 3, what's the sign of the answer?
11.
-11. What's the absolute value of negative 11?
11.
11, so I have 11 minus 8, which is tree. Tree. All right. So, what are you going to do in number 50? Oh. All right, so let's start. Again, there's a lot going on in that, right? The first thing we do is copy it. Get it on the board here. Okay, so what's the first thing that we got to do? Do we have a subtraction sign?
Yes.
So we have to change that. So I'm going to copy this part. Negative 8 plus 5. All right? Now, negative 8 plus 5. What's the sign? The sign is negative. So I have negative 3 plus 2. This makes it positive, but that sign says the opposite of positive. So that'll be negative 3 plus 2. Sign of the answer?
-1.
Negative 1. Okay? Now, very complicated problem. 4 steps involved. Not impossible to do, but complicated. But if you break it down with the skills that I'm trying to teach you, then you can do even one as difficult as that. All right? Okay? Does that make sense? So, in what we're going to work for our integer assignments, let's go back again. Okay, why are we going to write the sign first when we're doing integer work? Because it doesn't matter how you put it in the calculator, the sign is what the sign is, right? And how do we know? Because the greater number, the greater magnitude, that stack is going to be the one that becomes the correct answer. So if I have 34 plus negative 47,
It's negative.
the sign is negative, right? Okay, then with the calculator or with any other type of arithmetic, you can come up with the magnitude, but we already know the sign is negative. All right, now if I gave you the same problem that was like this, and it's a subtraction problem, we're not going to do subtraction because these skills we know. Right? The skills for subtraction are not simple. So what do we do?
Copy, change, change.
All right, copy, change, change, and now what's the sign of my answer going to be?
Positive.
Positive because
They're equal signs.
because the 47 is larger, but now I'm going to have this stack of positive integers and this stack of positive integers together, and so what am I going to do with these two numbers? Because the signs are the same, so you add them together, and in this case it looks like 1, looks like positive 81. All right? If you put the signs down first, you will make less mistakes. You make a lot, especially because most of the time in testing, to see if you get it, I'm going to throw negatives at you. Because how long have you been adding two positive numbers?
Forever.
Right? Since what, 3rd grade, right? But adding positive and negative integers, you haven't had a lot of practice on it, so you make more mistakes if I give you the opportunity. But what we're trying to do is we're trying to get the opportunity, but then do it the right way so that our math improves. Okay, so signs are different, we're going to subtract, signs are the same, we're going to add. And we're not going to do subtracting, we're going to change it because we know those rules. Okay, now, when we go to multiplication, rules change. All right, number one problem that I see when we start this is people get this, and then when they do the multiplying, they forget which operation they were doing. All right, so if I gave you negative 3 times 5 equals, and I gave you negative 3 minus 5 equals. Somebody talk to me. What do I do with that problem?
It's negative.
Why?
Because there's one negative.
Because there's one negative in the problem. Had it not been there, it would have been a positive answer like 3rd grade, right? But so there's one answer, so it's negative. And what operation do I use? In this problem, what operation?
Multiplication.
Well, so what is 3 times 5?
15.
But this answer is negative 15 because I already know the sign of the answer. Now, over here, what do?
Positive.
Well, now first is subtracting, right? So I do. Now, what's the sign of that answer? All right, negative. And what do I do with the numbers? Why?
Because it's the same.
Right, because of the same sign, so that's a negative 8. See, that's how the two rules go. If you don't do the rules differently, then what happens after you do multiplying is you start counting and you say, well, there's 2 negatives there, and that's wrong. Right? The reason that this is negative and we're adding is because the signs are the same, but over here the sign came because there was 1 negative. Does that make sense? Okay, good. If you recognize that, then this problem is just work. And there's a lot of it in this one, I'm sorry. I would like to have shortened this, but I've been told that people get confused if they have to go off the teacher page instead of off the assignments that Tandem put down. And so it's just a lot of work. But put the sign down first in your problems. Now, it's 9:03, good, we have. Now, if you two want to finish that last problem on your quiz, if you haven't got it done, you can now, because we've got class. All right, and the rest of you, is there any questions? Because I know I went by really fast. All right, does it make sense?
Yes, sir.
And I hope it does. I hope it does. Okay. All right, now, then let's talk about, this would be on the, okay. I'll put this up on the teacher page. Is that in section 3.2, this is the subtraction. And I am telling you that you copy the problems and you write the copy, change to turn them all to adding problems. When I'm going to ask you to bring your homework in. I'll send you an email to remind you. For next week, I want you to bring your homework in. I want to see all of those problems changed. Even if you know what the answer is going to be. Because just like with the one-step operations, in equations, we're learning a step of algebra that's going to be real important later on when the problems get harder. All right, so you're going to have to change them all, and I gave an example. This will be on the teacher page. And then write the sign first for multiplying, and then you can go ahead and use the calculator for the answer. All right, now that's going to be different because what happens if you copy the problem into your calculator, the calculator will give you the right answer. But I want you to put the sign of the answer down first so that you get used to doing the sign of this is going to be positive or the sign of this is going to be negative, and then you do whatever you have to do to find the number itself, the magnitude of it. All right, but those two skills, the changing skill and the putting the sign down first, it will help you in Algebra 1, it'll help you in Algebra 2, and it'll help you in college algebra. Okay, so don't try to skip it just because you can get it most of the times without doing it, because that's a skill that once you get used to doing it, man, it always comes up. And then your calculator, if the calculator lies to you, you'll say, wait a minute, that was supposed to be positive. Right? Which, again, that may save you a problem. Okay? All right, so that's the work. That'll be on the teacher page, and I believe that'll match. Where's my eraser? There it is, on the floor. Okay, and I'm going to turn this off.